Hi, I'm Jack. Today I will talk about cycl1 and today is January 25th. Cycl1. Cycl1 will be covered with chapter 13, 14 and 15. LAN architecture and WAN architecture and cloud architecture. So, chapter 13. We will cover network fundamentals. We have learned about Ethernet and switches before, and we learned how to work with it. So this chapter covers the topic with design-related considerations. Turns up 2-tier and 3-tier, which is describing how many switch layers exist between the endpoints and the devices. So let's start. This section we will talk about the topology of a campus LAN design. This is a design of large campus LAN. It has around 1,000 pieces or more than 1,000 pieces for sure, which connected to switches, and it supports around 25 ports each because large campus means they have large numbers of students, so it should have many access through various devices. We will check this later. At this moment, we should know that Cisco uses three terms to describe, which is access, distribution, and core. Depends on which switch forwards traffic from user devices or LAN, which is access, or whether the switch forwards traffic between the LAN switches, which is distribution, and core. So access, whether the switch forwards traffic from the user devices, and distribution and core, whether the switch forwards traffic between other LAN switches. Okay. Back to the picture. Alright, let's see the picture. Access switches directly connected to end users here, and it provides the device's access to the LAN. The point we should know is that access switches usually transport traffic to end from the end user. Devices to connected the edge of the LAN, so edge to edge. Okay. As we learned, distribution switch is in the middle of the path. Distribution layer, here, two switches. Which means that access switches can forward traffic to each other and to end. Also, each switch connects to at least one distribution switch. Normally, to two distribution switches for redundancy. Also, most designs use at least two uplinks to two different distribution switches for redundancy too. So this is a two-tier design, tiers being the access tier and the distribution layer. Tiers, I'm sorry. So, what are the advantages of two-tier? First is provides a place to connect end user devices, and it connects the switches with a reasonable number for cables and switch ports as 4-tier accesses switches to connect to two distribution switches. So I'm going to talk about the several common terms about LAN and WAN topology and design. First, star. It is just a star topology we learned before, but designed with one central device which connects to several others. And it looks like a star, so we all know how a star looks, so I didn't put the pictures in here. So this is mesh, which is a design connects a link between some pairs of nodes. And also even 6 switches, it consumes 15 links. Check the line in here. Next is hybrid, a design that combines topology concept into a larger. Next, 3-tier campus design. The next topic will be 3-tier design with core. Eventually, if the building have 2-tier design building, we'll have problem with connecting the LANs in each building. This is not a 3-tier but 2-tier building without core. Without core 3 buildings. So the design looks very good and it is common used. However, the point what I want to make here is that the design with the third tier, it saves on switch ports and on cables in larger designs. Also, the links between buildings, the cable runs outside. They're often more expensive to install because it is fiber cabling, which means conserving the number of cables used between buildings can help reduce cost, for sure. The three-tier core design, we put more switches to connect the distribution switches. Like this. Very simple. By using the core design, core in the middle, partial mesh of links in the core, it will provide connectivity to all parts of the LAN to the routers, which sends packets all over the WAN with these simple changes. Okay, and next is Soho. Small office, home office. Comparing with big buildings, this will be the small office and home size. The design differs significantly to the IEEE defines both Ethernet LANs and wireless LANs. We use our Wi-Fi at home, and the basic setup will look like this. We have router and devices and cable and internet in our house and small office. So in this picture, we see the router, but this router acts like separate devices. We can find an enterprise campus too. Also, this picture, we just added some more devices. It explains that a single consumer wireless router, it can also be like several different devices too. So it's not different picture with the before one, but I just want to show the details of the structure. Okay, next, PoE, Power over Ethernet. We see the cable lines and some outlets in our buildings, and the electrical outlets are everywhere. So PoE, this takes the responsibility to provide electrical power to some devices, which can fall to the network engineering team. So by using PoE, we can get several advantages. Versus, it reduces the cost by requiring fewer cable than old style cable. This is a picture of PoE basic structure. So this is connected with AC power cable and PSE, power sourcing equipment. It supplies DC power over the Ethernet UDP cable, and through the DC power, the device receives the power. PoE has great advantage of devices installed to locations that often do not have a pre-installed power cable or power output. Power cable or power output, sorry. And let's go to the chapter 14. We will learn about network fundamentals and security fundamentals. Metro Ethernet. Metro Ethernet includes a variety of WAN services. The services is a layer 2 service which WAN forwards Ethernet frames from one customer to another. Metro Ethernet acts as if the WAN service were created by one Ethernet switch. In this picture, it shows 4 sites in the same company, and each router is connected to the WAN service. The main concept of Metro Ethernet is such a big LAN switch, so many options and many users will connect to the Metro Ethernet with layer 3 switches or routers. So I would like to talk about Ethernet line service. This is a point-to-point style, and this is the simplest Metro Ethernet services. As we can see, it's only one line. So this picture shows the Metro Ethernet with routers as a CPE devices. Okay, so there's so many concepts of Metro Ethernet, so I will move on to the layer 3 structure with ELAN service. I love numbers in network class, like this. Routing table, interface, subnet, yes. So, in this picture, layer 3 forwarding between sites with ELAN service. When we see the subnet, router 3 and router 2 subnet is 10.1.2.0 and others. And next hop address by router 3 will be 10.1.99.0. After that, it will send packets directly to router 2 like this. Also, another router 1 and 4 in here will be the next hop address. It hasn't been marked in here, but it will hop in here too. This picture briefly shows an example which includes subnets and address, and 4 different routers are connected to the ELAN services. This is very interesting. MPLS, multi-protocol label switching. Well, the word itself is not that interesting, but the example and the concept of MPLS is very interesting. So each devices are making a separated forwarding decision to forward the packet. Very simple. IP goes here, 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 here. And each one makes a comparison between the packet's destination IP addresses. It tells the router where to go and send the packet next. Very easy description. As arrows are going and pointing, they show the direction to forward, and the SP creates its own UP Ethernet up network, and spanning to other area. So it means that if user connect to the MPLS network from each site, SP routing IP packets from one customer site to other two. As we can see in the picture, 4 router in the middle. This is SP's MPLS network. Various routers by one company, 1, 2, 3, 4, in here in the middle. Next, chapter 15. Let's talk about cloud architecture. The word cloud is very familiar to us, and cloud computing is not a product. There's so many cloud services, and sometimes people get confused with what does exactly cloud mean. Well, I would say it is just a broad knowledge of networking, and it is not a protocol or products. It is service to customers. Cloud relies on data centers that can be automated. Okay. Server virtualization. Server. So what is server? It can be varied. For me, I would say program helps to access to the centralized resource or network. The answer can be different. So yeah, for me, I would say it like that. So next one. No KVM. So for servers, all users and admin connect to the server over the network. Thus, there's no reason to permanent keyboards and other devices, as we know, and racks on servers in a data center. Companies put many servers into the room, a data center, to save the space, so that it will fit in standard rack with more space. I would like to talk about server virtualization basics. This is a physical server model with hardware, one OS and applications. Each one runs one OS, and in that server OS uses all hardware. However, nowadays, most companies create a virtualized data center. Company purchase server hardware. It treats all the CPU, RAM, so this is what you call VM, virtual machine. Okay, and a VM, OS instance decoupled from the server hardware, still must execute on hardware. It has individual configuration as minimum number of vCPUs it needs. So its VM is running on the physical server with CPU and RAM. This is 4 VMs running on one host. Hypervisor manages the hardware to run virtualization. Each one should use hypervisor. It manages and allocates the host hardware. Each VM runs as it is running on a self-contained physical server. Fantastic! So if one VM happens to be configured to use 4 CPUs with GB of RAM, this hypervisor allocates the specific parts of CPU and RAM so VM can use it. Okay, so I think this is also important to know. This is a basic networking in a virtualized host with a virtual switch. So there's 3 points I would like to talk about. Ports connected to VMs. The vSwitch can configure a port so that the VM will be in its own VLAN. And second, ports connected to physical NICs. The vSwitch uses the physical NICs in the server hardware. Automated configuration. The configuration can be easily done from within the same virtualization software that controls the VMs. And also, this is based on the book. I couldn't find other great explanation for this, and I really think this is really important to know. Next, cloud computing services. This is very easy. Cloud computing makes use of products such as virtualization products, but also uses products to cloud too. We have on-demand self-service, which is consumer choose when to start and stop using the service without any direct interaction with the provider of the service. Next is broad network access. The service must be available from many types of devices. And resource pooling. The provider creates a pool of resources and dynamically allocates resources from that pool for each new request from the consumer. Next one, rapid elasticity. To the consumer, the resource pool appears to be unlimited. And measured service. The provider can measure the usage and report that usage to the customer, and both for transparency and for billing. Alright, this will be the first cycle presentation, and I want to tell you guys that this cycle, there's so many resources to learn and get used to it. It was a very interesting topic, but also we had to study deeper too. I really had to study more. Thank you for watching. I will come back with better quality video for next week. Thank you so much.